Alright, so it's New Year's Day, and it's time to finally fix the tach problem. The way we're going to tackle this is, it's all about resistance. And the resistance is going to change based on your tach, what your tachometer wants to see. The output signal from the GM PCM is always going to be the same. The problem is most of them are too weak for these to read because the systems that they use run off of a CAN bus. So very small amounts of signal to get a good response for that complete setup. And what we're going to do here is have an assortment of a few things, a couple of small things. So inside this box I have, if I can get it to focus, there we go, I have all kinds of resistors and transistors and capacitors and things of that nature, even some LEDs. I use this. I thought I was going to teach myself how to code and play with some electronics, but that's on hold right now. And this color code chart, because you don't have to remember all this stuff. You can Google it on the internet. It's the easiest thing to do. Memorizing it, that's only because you do it too much. So with that, there's an infinite combination here of resistance. So that's good. But how do you figure out what your tachometer wants to see? Especially if it's an aftermarket tachometer, like Autometer, or in my case a cheap Sunpro from O'Reilly's or Advanced or AutoZone, wherever I got it from. So this is what we're going to start with. 10K ohm resistor. See if we can see that. 10K? Alright, so a 10K ohm resistor. And basically what we have is this right here, this center pin. This will be our output to the tachometer. On this side, this is going to be our signal in. No. This side will be our signal in from the PCM, and this side will be our 12-volt power source. And this is going to act as a pull-up resistor. Basically, all it's going to do is very cheaply and effectively amplify the signal coming from the PCM. Now, what we'll do is solder some wires on, get everything connected up the way I just showed you, which will be signal out to the tach, signal in from the PCM, and 12-volt power on this pin. Then we will change the resistance value until the needle on the tach functions the way we want it to, where it doesn't bounce at low RPM, and in my case actually starts to read properly. I didn't look at the resistor that I have in it right now. Actually, I have it in my hand. I cut it out. But I'm going to look at those color charts to see what I put in. I'm thinking it's probably about a 10K. See what I actually put in. And I just put in a high resistance value just because without this, without the resistor, if you just hook 12 volts up to it, you're literally putting a path straight to 12 volts, and it would feed back into your PCM. You don't want to do that. It will fry your PCM. If it doesn't just fry the tach signal coming out of your PCM, it may actually fry more than that inside of it. So whatever you do, do not think that you can take 12 volts and hook it straight up to your feed out of your PCM for your tach. You will definitely fry it. You have to have that resistance, or otherwise you just have a direct path. I'm going to pause the video, and after I set all this up, I'll show you what it looks like, and we'll go on from there. Okay, so we're back. That didn't take very long. If you've never soldered before, just remember, maybe you've welded. Soldering and welding hold one thing that is key, okay, and that is heat. What dictates the amount of heat that the product absorbs is not necessarily amperage. Now, yeah, that's going to dictate how much heat you can effectively put into it, but that is not the sole thing that decides how much heat gets put into the device. What decides it is time. And it doesn't matter if you're welding thin steel or aluminum, or if you're soldering these little pin connections. Time is what's going to destroy what you're doing. So be quick, be effective, and try to minimize the amount of time that you actually have it on. So you notice, have it soldered. The gauge of the wires really doesn't matter, but I use way heavier gauge than what I actually need for this. the gray and the white wire are 18 and the red feed wire is 16 gauge. But that way I know I don't have any problems with resistance. I could probably just use a couple strands and the resistance value would still be good. So we're going to get this hooked up to the engine and then start it up and go from there. Okay, so it's been a little bit of time. I couldn't get the resistor to the potentiometer to work because I found out that the tach is actually messed up. I tried to go ahead and solder in an actual resistor. This is a 4.7 K-ohm resistor, just to be in the ballpark of what I'm pretty sure it's going to need, and I can't get it to go at all. So what I did was set the fluke back up to measure millivolts DC to make sure that the PCM is still sending out a tach signal. And as you can see, now the PCM's on. Let's see if we can get a better view of that. Start the engine. You can watch and see the voltage change with the RPM. So I know the PCM is still putting out signal. Give it some throttle, you'll watch, see the millivolts change. One of the keys of that is you can even hear when the engine stumbles, and at that same time you can see the correlation to the millivolts changing, and that is a good sign. I thought that I may have burned up the tach signal leaving my PCM, but apparently that's not the case. For a good thing, that's not the case. You also notice that I managed to fix the hard start without having to give throttle input. I gave no throttle input. Granted, that's the second or third time I started it to verify this. However, I fixed the problem last night. And what I did was, I may or may not have shared this before, but initially my PCM, I just realized I need to fix a problem. It's not fused right now, but initially my PCM was coming off of this pin right here, and it was just this fuse for the all-time high for the PCM. That's what helps it maintain memory. Problem is that this power supply is a switched power supply. So every time I would turn it off, it'd be like disconnecting the battery, and the PCM would go through a relearn state, verifying the position that you put the TPS sensor. That's my big problem. Every time you adjust these, you have to remember that the PCM goes to a relearn state. And if you back down the throttle for idle on the blade by shutting the blade, then it's going to maintain that value unless you disconnect the battery from it. If you don't disconnect the battery, i.e. this power to here or the negative battery terminal, which is what's recommended, then it's going to maintain whatever the initial value was set in. So anytime you back off the throttle and lower the RPM of the engine at idle, you have to reset power to the PCM. You can gain, once you have an initial base, you can increase the idle, and the IAC will still function properly and the PCM will still control it. But if you try to lower it, it will mess up everything. So make sure that you do that. I'm going to continue troubleshooting. I have more gauges. I think I actually have one in one of my piles. Oh, what do you know? Looky here. I know there's some pro gauge. We might have to hook this one up, see if it functions, and plus, it's bigger. Just a little bit. Not too much. Yeah, that'll work. So try and get this all wired up and mounted, and then see if we got a good working tach. Alright, so just did a little soldering real quick, hooked up the 4.7K ohm resistor, and hopefully, there we go, you can see this better. Ignition on, haven't started it yet, but you'll be the first to know. Oh, that's a good sign, see the needle rise? We'll be good to go. This thing's burning through a lot of fuel. Fuel trim is definitely a little off, so I had to figure that out. I put probably 2 gallons in it yesterday. I ran it for a total of 10 or 15 minutes, maybe 20, maybe 45, I don't know. And it only had like maybe half a gallon left, if that. So figure that out. But all the black smoke out of the back and tells me that it's overfueling. It's not a diesel. And even so, that's what they do, overfuel. So hope you enjoyed this, and maybe some questions are answered. Let me give you a little detail of how this is wired in. So on all these gauges, actually I'm going to take you out of the mount. It makes it easier because I'm actually using a vise, a small vise. I said I was probably going to invest in something, and I didn't. I just put a rag and a small vise. I'm going to use that as my camera mount for right now. Right. So, show you some details. So coming out of, figure out this camera angle, the tach. You have green, which is your tach signal to the tach. Positive, which is red. Black, which is your ground, and this white wire is always your light, your illumination. So what we did here was we have 12 volt power coming in all time. Well, it's not all time hot. This has to be on a switch source. You don't want to continuously feed 12 volts through there. On the other side of the resistor, you'll see my big glop of solder. On the other side of the resistor, we have the wire, the tach signal coming in from the PCM right here, and then tach signal going out to the actual tach itself. And functions great. Tells me that I obviously messed up that, and probably just gonna throw it away. So, got any questions, anything else you want to see, let me know. I'm gonna keep chugging along.